Steamboat was a perfect place because it's the right distance from Denver to set the example.
Steamboat is kind of an isolated community relative to the rest of Colorado. It's in the far northwest corner. You have to go through at least one, if not two or three mountain passes to get there.
We had a lot of things going for us. For example, there was a Colorado grant that fit this facility. It happened to fit our machine. Everything worked out, so there was very little risk to the people that were using it, which allowed us to really get in here and show what the machine can do.
Steamboat Springs was trucking all of their recyclables to Denver, and in doing so, they were reducing the load on the landfill, but they were also reducing the number of jobs at the landfill. So doing the right thing actually cost the community in terms of jobs and economic output. The net result is you get rid of a lot of handling. You get rid of a lot of the damage that caused contamination and ended up sending things to the landfill 180 miles away. You take a good number of trucks off the road, and at the same time you create, basically in this town there's 8 people that have jobs here because they're sorting.
We're cutting out all of those middle places. We're going to touch the material one time on the Revolution. After you touch it one time, it's going to be in a package. We don't need to ship it to the big city MRF.
The old process, truck comes up to your house, empties your recycling bin into the truck collects from a bunch of other houses, and then goes to a transfer station. They dump the truck out, and then a wheel loader will take that and load it into another truck, and then it drives to the sorting facility in the big city, closest one that's there. In this case, it was Denver, which is 180 miles one way, and then drops it off in Denver, and then that truck comes back empty, 180 miles, and comes to pick up another load. And now, with the Revolution, the material is still picked up at your house, but instead of going to the transfer facility, it comes here to the sorting facility where it's sorted locally. It's baled after sorting and packed into a truck that carries 21 tons a load, which is a lot more efficient. And that truck typically is a truck that had dropped something off at, say, Walmart or the furniture store, the hardware store, or maybe even the grocery store. And that truck will come back and it'll pick up those cans, or it'll pick up that paper, and it'll take it to its next station in life. Things that we take for granted, like the ability to have curbside recycling in most of the big cities of the United States, that's not something that you can count on or even imagine in smaller towns, where in some cases your environmental quality is a lot more important.
The small communities, 20,000 people, 30,000 people, spend $500,000 and you can process all your material. Where prior to this machine, you were spending $2 million to get just the equipment. That's no labor costs.
It seemed to me that if we could turn all of these big projects that cost millions of dollars into a product that costs a lot less than that, we could enable communities to not just recycle their waste, but reduce their reliance on landfills, improve the jobs in the local economy, and take a lot of excess wasted activity and turn it into something that was a little more productive.
Instead of spend $100 a ton to get it to Denver, we're going to get paid for selling the material. On a linear system, when you're sorting, you can only drop material in the chute that you're by. All of that material then goes into a bunker or another container and handled separately to be baled. On the Revolution, the circular design allows one person to do up to 3 materials without moving. And if he doesn't have enough, he can help the guy next to him. Or if the guy next to him runs out, they can work together. The Revolution will always use 30% less labor than a traditional linear system.
There's a lot of automation that's in recycling that actually is detrimental, because in some cases it doesn't discriminate good paper from bad paper, or it tends to mix good paper with bad paper and contaminate the system.
Most automation can't make the decision. Does that pizza box have pepperoni grease in it, or is it clean? When the market is the situation that it is now, if you don't have the top quality, they're going to the guy that does.
There's another aspect to the revolution that I think is worth talking about, and this is the idea of control. Control of your material, control of the value that you generate. Communities haven't had the wherewithal to do the processing locally and do it themselves, so they hire it out to other companies who typically will charge for the transportation, and they might share a little bit of the upside on the sale of the material with the community. Revolution lowers the bar for having that kind of control, and it lowers the bar for retaining that value in the form of jobs, and in the form of profits, and in the form of efficiency and ownership. Let's talk about the economics of recycling. Recycling's value is all about materials and energy. And what you get when you look at the cost of that can at the end of the day is the sum of all the material and all the energy that goes in. The value in recycling comes from recovering that material and energy that's already there. In some cases, like glass, the savings in material and energy works out to about 30%. It's actually cheaper and less expensive to melt old glass than it is to make glass from scratch. In the case of plastic and in the case of aluminum, it's a lot higher. Aluminum is about 80%, plastic is about 90%. This is important because we can burn up all that energy and all of that saved value very quickly. And this is how typically recycling businesses get in trouble. And that's where revolution comes in. We take those steps out, and at the end of the day, we make sure that it leaves town in its most efficient and most compact manner. The sooner you can turn it into a bale, the sooner you can sort it and make it a bale of plastic or aluminum or paper or cardboard, you're getting it into a configuration where that's the optimal solution and that's the minimal amount of energy expended to get the material back on its way. It was a challenge to try to get the machine where it needed to be, and I knew that it was a challenge to have the kind of flexibility that we needed to have. And I think I said something along the lines of, I don't know, I can't figure it out. Best thing I could come up with is what we do in manufacturing. We try to make it round, and we try to bring a lot of teamwork into it.
He kind of gave me the criteria, and it needed to cost less than $500,000. It needed to be able to be operated in a 5,000 square foot building. It needed to be operable by one person. I told him it couldn't be done. Over the next, 6 months or so, I started messing with it and came up with this design in it. And then after we built the first one and I actually walked on it for real, I said, this is way better than I thought it was going to be.
Dan's taken a look at not just the cost of the machine, but at the total cost of operating the system, because that's really what makes the difference for our customer. We could have the cheapest machine in the world, and if it still costs them too much to have a building or costs them too much to run it, we haven't really done anything. On your power bill, there's this thing called the demand charge. The demand charge is what the power company charges you for making power available. And it has less to do with the actual power delivered and everything to do with the amount of power and the magnitude of power at the time you ask for it. When you're running a recycling facility, you've got a lot of motors, you've got a lot of pumps, you've got a lot of things that have the potential to increase your demand charge. When electric motors and machinery get started, they draw an awful lot of current. If, however, you've got a control system like we do on the Revolution that coordinates how all of the machines function together, you can keep that demand charge low because that's a significant impact for customers.
Well, this particular one doesn't use any generated electricity because it's solar. Our solar panels will produce 150% of the power that this machine requires to run.
We can now power the machine with solar panels that fit on that roof. Not any other roof, not more roof, not in the lot next door, but that 5,000 square foot or 6,500 square foot roof that we stick over the machine is adequate.
I really like it because I haven't seen a power bill.
The Revolution is takes 30% of the space of a comparable system. And the way it does that is through reducing the amount of space and time and distance that the material travels. The future is a more integrated system. The core of the Revolution is the round circular table with all the ancillary equipment. As we get further down the road, that equipment is going to become less and less unitary and more integrated.
I would like to see these every 100 miles in all the rural communities. I would like to see us producing and processing and making products out of all of the material all over the country. Because that's the problem with all of this material, is not enough people are using it.
Revolution Systems' success is based on the idea that we earn our keep and that we are a good investment for investors, and we're something that my family and Dan's family can feel comfortable that we're doing, so that we can continue to do what we're doing, and we can continue to have other stories like Steamboat. And so when you consider a company like Revolution Systems, when you look at the profit and loss, you're not looking so much at a profit and loss of jobs and people, but you're also looking at a profit and loss that's driven by material and energy. And if we're really worried about our environmental impact and minimizing that, we need to be reducing the amount of material and energy that goes into everything that we do and everything that we make. So if we're losing money, we're probably losing on the environment too. The more we drive down the cost, the more places we can deploy the machines, the better, the more impact we have, the more we learn, and it just starts to, hopefully it's going to start to snowball.
Now we've created this, we've developed something out of it. Now I'd like to see it all over the country, if not the world, and I'd like it to be, I want to see it to be the standard.
Somebody who doesn't work in manufacturing probably doesn't understand or have an idea of all the things that happen here. All they know is that, they put it in a bin and they trust that it works. And it's our job to make sure that that happens.